All right, so for our next equation that we're looking at, there's several things going on here. We are looking at the limit as x is approaching infinity, so we're looking for end behavior. Basically, we want to see what's going on when x is approaching infinity. So we're looking for all the stuff that's going on over here. And with that being said, too, we also have quite a few exponents here. And we're going to need to use limit laws to go ahead and break this down a little bit easier to solve. So the limit law that you need to be familiar with is that the limit as x is approaching infinity, or if x is approaching negative infinity, either way, of 1 over x to any power is going to be 0. So we're going to use this rule or limit law to break this equation down and make it easier to solve. So I think the first thing to do here is to go ahead and rewrite the equation, factor everything out together so that way it's a little bit easier to see what's going on here. Okay, 4x squared plus 1 for our top guy there. And then if we first go ahead and, I already have it pre-factored to the side here, but if you want to break it down, you could go ahead and first go ahead and factor out the x minus 1 squared and then combine those together. However you want to do that, you're going to end up getting x to the 4th minus x cubed minus x squared plus x. So that's just expanding this all out so that way it makes our next steps a little bit easier, because the way that what we need to do to this equation to be able to use that limit law, we need to go ahead and divide the top and bottom by the highest degree term in the bottom. So our highest degree term here in our denominator is going to be that x raised to the 4th. So we're going to divide both the top and the bottom by x to the 4th. So an easy way to go ahead and look at that is to write each individual term out, term by term division. So we would have 4x to the 4th divided by x to the 4th plus 4x squared divided by x to the 4th plus 1 divided by x to the 4th over, might need a little bit more room there, x to the 4th divided by x to the 4th minus x to the cubed over x to the 4th minus x squared over x to the 4th plus x over x to the 4th. Yay! So much writing. Okay, so now that we have that, it's just a little bit easier to see how those divide out. So then that ends up being the limit as x approaches infinity. The x to the 4th here ends up canceling out, so we end up having 4. And then over here, we end up with our plus 4 over x squared. And then for that last one, we just end up having the 1 over x to the 4th. And that's all over. The x to the 4th here ends up canceling out to just be 1 minus 1 over x minus 1 over x squared minus 1 over x cubed. So again, this here is just the result of us dividing by that x to the fourth. So now from here, we can go ahead and use our limit laws. So if we go ahead and write in each of those limit laws, it's going to look like this. So I guess I don't need to write the big one. Hold on. Save us some space. Okay. Make our fraction bar. There we go. So the limit as x approaches infinity of 4 plus, and for this one here, this is really the same as saying that we have 4 times 1 over x squared. And if you remember the constant multiple rule, we can go ahead and take that constant, the 4, out and put it in front of our limit, and we'll just multiply it by the limit. So that would be 4 times the limit as x approaches infinity of 1 over x squared. So again, this 4 is just being pulled out in front of the limit, and that leaves us with our 1 over x squared going there. That's what we did there. And then our last one, we add the limit as x approaches infinity of 1 over x to the fourth. And then on the bottom, we have the limit as x approaches infinity of 1 minus the limit as x approaches infinity of 1 over x minus the limit as x approaches infinity of 1 over x squared. Sorry, my handwriting is getting a little messy here. The limit as x approaches infinity of 1 over x cubed. Beautiful. And now we just want to solve for those individual limits. And then we'll kind of put them all together. So our first one, the limit as x approaches infinity of 4, that is going to be a constant. So that's just going to be 4. And then here we have 4 times the limit as x approaches infinity of 1 over x squared, which is going to be 0, plus the limit as x approaches infinity of 1 over x to the fourth, which is going to be 0. On the bottom, we have our limit as x approaches infinity of a constant, which is 1, so that's just going to stay as 1, minus our limit of 1 over x. And really, we don't have any constants here. All of these are terms over x to a certain degree. Those are all just going to be zeros. So we just kind of put those zeros in. So ultimately, we're just left with 4 over 1, or our answer of 4. So the limit as x approaches infinity of 2x squared plus 1 squared over x minus 1 squared multiplied by x squared plus x ends up being 4. So big things to remember when looking at these types of equations where we're solving for the end behavior, and we have a lot of these exponents. Look for that highest degree term on the bottom, divide both the top and bottom by that term, and then use your limit laws to solve. All right, hopefully that helps you out with those types of problems in the future.